So hello everyone, let's continue our lecture on Laplace transformation. As this is fourth lecture on Laplace transformation, in the previous three lectures I have discussed about some basic formulas and some simple numerical problems which carries 2 marks and can be asked in exam. And here in this lecture I will discuss about the problem in which we will see the algebraic term or the trigonometric term having multiplication to the power t to the power n. So, and you guys do me a favor, do watch the videos of lecture 1, 2 and 3. Those lectures are very important to continue with the lecture 4, because in those lecture I have discussed with the formulas. Also I have shown the derivation of some formulas which you do not need to recite, just learn the derivation and you will be able to use the formula when we will come to face those formula in the other numericals. So without any further delay, let's get started. So here when we face the formula having the multiplication by t to the power n, it gives a condition, that is, if Laplace transformation of function f in terms of t equals to fs, then when it is true, then what happens? Laplace transformation of t to the power n f t will be equals to minus 1 to the power n times derivative to the power n upon d s to the power n in the form of fs. What it says, let me show you, where n equals to 1, 2, 3, 4. Now this condition you must remember when we are going to solve any problem which are given in the form of multiplication by t to the power n, and for that I have selected some numerical problems which I am going to solve in this video and make you clear with this concept when the problem is in the form of multiplication by t to the power n, where n is number 1, 2, 3 and 4 and so on. So here you can see that our first numerical problem is t to the power 3 times e to the power minus 3t. Here also this exponential function is multiplied with t to the power 3, that is t multiplication by t to the power n. Similarly we can see that our second problem is two trigonometric functions which are being multiplied with t. Similarly we have third numerical problem, that is exponential and trigonometric function are in the product form and that is multiplied with t square, that is t to the power n form. So let's proceed with the solution of numerical 1, and then as we proceed with the numericals the difficulty level will increase, and such type of numerical carries the highest mark in the examination. So do continue with the lecture till end. So let's continue the solution of the first numerical, that is t to the power 3. Question is t to the power 3 times e to the power minus 3t. So again write down the solution, and if you guys have watched my first lecture, you have known the formula, that is Laplace transformation of e to the power minus 3t. Laplace transformation of e to the power minus 3t will be 1 upon s plus 3. When we have e to the power minus 3t minus, it will get plus and s plus 3. That is the formula for exponential. Do watch those videos, link is in the description. Now again Laplace transformation of tq times e to the power minus 3t will be given by, we have t to the power 3, and now use the condition. We will have here Laplace transformation of t to the power 3 t to the power 3 times ft. In place of ft we have e to the power minus 3t, so we will have here minus 1 to the power n, and in place of n we have here 3, so minus 1 to the power 3 times and we know that we have to do the derivative third time. So put cube here, we have 3 t to the power 3 means we have to do the derivative 3 times. So d to the power 3 times s, our variable is going to be s, because we have already converted e to the power minus 3 to 1 upon s plus 3. So we will have here s to the power 3 times 1 upon s plus 3. Now we will proceed further. Now you need to learn how to do the derivative 3 times. See here, we can rewrite 1 upon s plus 3 as 1 s plus 3 to the power minus 1. We can rewrite it as s plus 3 to the power minus 1, and we have to do the derivative 3 times. So we have this equation in the form of ds to the power 3. Now when we will do the derivative first time, what we know the formula that derivative of x to the power n upon dx will be equals to n times x to the power n minus 1, and in place of x we have s plus 3. So we will have here d square ds square, and derivative of s plus 3 to the power minus 1, s to the power 3 minus 1 with respect to ds will be n, means minus 1 times s plus 3 to the power minus 2. Actually what happens here, we need to use the chain rule here, so this will get elaborated as s plus 3 to the power minus 1 upon ds plus 3 times ds plus 3 upon ds. When we open this, then it will get converted into this form. Now if we do the derivative of s plus 3 to the power minus 1, then it will get as minus 1 times s plus 3 times derivative of ds plus 3 is 2s, derivative of ds plus 3 is derivative of ds plus 3 by ds will be equals to 1. So we will, when on doing the derivative first time, we will have here minus s plus 3. Now we will do derivative 2 more times because we have power 3, so we will rewrite it as d upon ds, and on doing the derivative for the second time, what we will do, we are finding the derivative of minus s plus 3. So keep this minus in the front side, so we will have a ds plus 3 upon ds plus 3 times ds plus 3 upon ds. So derivative of x to the derivative of x with respect to x, it gets 1. So this term will get 1, and derivative of ds. Now let's learn to find the derivative of third times, derivative of dsq and 1 upon s plus 3. So we can rewrite it as, 1 upon s plus 3 as s plus 3 to the power minus 1. So if we find the derivative first time, so I am going to write it here, s plus 3 to the power minus 1. It gets in the form of ds plus 3 to the power minus 1 upon ds plus 3 times ds plus 3 upon ds. If we open this, then it will get this. This is the rule of derivative. So we also know that derivative of x to the power n with respect to x equals to n times x to the power n minus 1. So we will have here n means minus 1 times s plus 3 to the power minus 2 times derivative of s plus 3 upon ds. Derivative of s plus 3 upon ds is ds upon ds plus d3 upon ds, and derivative of constant is 0, and derivative of ds upon ds will be 1. So we will have, on doing the derivative of s plus 3 to the power minus 1 for the first time, it will get minus s plus 3 to the power minus 2. Now we have to do the derivative second time also. So doing the derivative second time, we will have here derivative with respect to s minus s plus 3 to the power minus 2. So we will bring this minus sign. This is second times derivative, and this it was first times derivative. We will need to do 3 times derivative because we have power 3. So on doing the second times derivative, we will have here minus, bring this minus this side, and we will have the form d upon ds s plus 3 to the power minus 2. Now it will get rewritten as d upon d s plus 3 to the power minus 2 upon ds plus 3 times ds plus 3 times ds. Again derivative of ds upon ds, it will get 1, and derivative constant is 0, so we need to operate this only. So we will have here minus and minus 2 x to the power minus n means minus will get multiplied with minus 2 and s plus 3 to the power minus 2 minus 1 minus x to the power n, derivative is n times x to the power n minus 1, and here n is minus 2, so minus 2 minus 1 will get minus 3, and here derivative of s means 1 plus 0 will get 1, so on multiplying this we will get 2 times s plus 3 to the power minus 3, and again we need to do the derivative third time, so we will have here d upon ds, and derivative of 2 times s plus 3 to the power minus 3, we will get here 2 times and the derivative of again x to the power n is n times x to the power means s plus 3 to the power minus 3 minus 1 will get minus 4, and derivative of d, derivative of s and 3 will get again 1 and 0, so we will get this result. So on doing on multiplication we will get minus 6 times s plus 3 to the power minus 4, which can be written as minus 6 upon s plus 3 to the power 4. Now we have known that it will get minus 1 to the power 3 means minus 1 times minus 6 upon s plus 3 to the power 4. So our final answer is going to be 6 upon s plus 3 to the power 4. This is our final answer. Now let's move toward the solution of the second numerical example, that is question t times sine 3t times cos 2t. So write down the solution, and first of all let us find the Laplace transformation of sine 3t times cos 2t. So we know that Laplace transformation of sine 3t times cos 2t. Now here comes a concept that I have already mentioned in the previous lecture, that whenever we come to see the trigonometric function in the product form, we cannot operate it in the Laplace transformation. So for that we have to change it in the expression form. How we can change this? We have learned the formula of 2 sine a into cos b, 2 cos a into sine b. We have I have already discussed about those formula in the previous lecture. You can go through the thumbnail also, you will come to know when you check the playlist and watch for the thumbnail, you will come to know it is inside. I have discussed about those formula in the second lecture, you can easily visit that. So we know that we have how we can convert this product form into the sum or into the form of expression. We need to do the multiplication and division by 2, because we have the formula that is 2 sine a into cos b, 2 sine a into cos b. So we have to change it in that form. So for that what we will do, we will multiply this as Laplace transformation of 2 sine 3t times cos 2t. So it is in the form of 2 sine a times cos b. So we have the formula 1 upon 2 sine a times cos b will be equals to Laplace transformation of sine a plus b means 2t plus 3t is 5t plus sine a minus b means 3t minus 2t will be equals to t. Now we also know the formula of sine at. We know that Laplace transformation of sine at equals to a upon s square plus a square. Similarly Laplace transformation of, we will not require the formula, Laplace transformation of sine hyperbolic at is equal to a upon s square minus a square. I have already discussed this formula, so we will use this formula here because it is not the hyperbolic function, it is simple trigonometric function. So we will write here 1 upon 2, and Laplace transformation of sine 5t will be equals to 5 upon s square plus 25 plus Laplace transformation of sine t will be equals to, in place of a we have 1 here, so 1 upon s square plus 1. Now we have converted this successfully in the form of s. Now we will find the Laplace transformation of t times sine 3t times cos 2t, and we will use this operation here. So we have here now Laplace transformation of t times sin 3t times cos 2t will be equals to minus 1 to the power n. In place of n we will put 1 here because we have t to the power 1. So it will get 1 times d. We have to do derivative only once here in this problem. So and fs is 5 upon s square plus 25 plus 1 upon s square plus 1. Now we have to find the derivative of these two terms. Or let me elaborate once again. So we will have here minus 1 to the power 1 means minus, and we have to do the derivative ds 5 upon s square plus 25 plus d upon ds times 1 upon s square plus 1, and put the bracket here. What I did, we have to find the derivative of these both terms, so I have multiplied the both term with d upon ds to find the derivative. So we got this. Now I am going to show you how to find the derivative of these terms. See here, we have to find the derivative of d upon ds 5 upon s square plus 25. So this is constant, we can bring this ahead. So we will have here 5 upon d upon ds times s square plus 25 to the power minus 1. So we will have here 5 times minus 1 times s square plus 25 to the power minus 2. What I did, this is in the form of x to the power n. So n times x to the power n minus 1. Minus 1 will get minus 2, and derivative of s square plus 25 will be 2s. Why this happened, I show you this in the earlier also. What happens here, see, d derivative of s square plus 25 to the power minus 1 with respect to s, it will get converted it as d derivative of s square plus 25 to the power minus 1 upon d s square plus 25 times d s square plus 25 times ds. This gets converted into this. This is chain rule because these two gets cancelled, and in order to find the derivative of x to the power n, we need x below. So this whole x as x. So x to the power n, we need x on the denominator also. That's why we apply chain rule here. So now derivative of x to the power n means minus 1 times s square plus 25 to the power minus 2 times derivative of s square upon ds. This gets splitted as ds square upon ds plus d 25 upon ds. So derivative of ds square upon ds is 2s times s to the power 2 minus 1 will get 1. Okay, x to the power n means n times x to the power n minus 1. 2 minus 1 will get 1 plus derivative of 25, constant is 0, so we will have here 2s. Okay, so on doing the integration, derivative, we got minus 2s times s square plus 25 to the power minus 2. We can rewrite it as minus 2s upon s square plus 25 and whole square. Now we have second term also, that is derivative of s square plus 1 to the power minus 1 with respect to ds. So we will again use the same rule here, that is ds square plus 1 to the power minus 1 upon ds square plus 1 times ds square plus 1 upon ds. So again chain rule, that is minus 1 times s square plus 1 to the power minus 2 times 2s. So we will have here minus 2s times s square plus 1 to the power minus 2. So we will have here minus 2s upon s square plus 1 and whole square. So we are going to use this both the derivative value here. On doing the derivative, what we got, minus and put the bracket, we first got 2s upon s square plus 25 and whole square, again this minus 2s upon s square plus 1 and whole square, and we have this 5 also, so 5 times this. Now what we can do here, and here we have this 1 upon 2 also, this is 1 upon 2, so I am going to bring it here 1 upon 2, this 1 upon 2, so we will have here 1 upon 2 and 2s. So what I am going to do here, I am going to multiply this with minus and take 2 common, so 2 will get cancelled out, so we will have here 2 will get cancelled out, so we will have here 5s upon s square plus 25 square plus s upon s square plus 1 whole square, and this is our answer for this numerical. Now we will proceed to the third numerical example, that is question t square times e to the power minus 2t times cos t. Again the rule is same, we are asked to find the Laplace transformation of, first we will proceed with these two terms, Laplace transformation of e to the power minus 2t times cos t. So we know that Laplace transformation of e to the power at minus at times cos bt or cos t will be equals to, cos means s and this a, this is minus, so s plus a upon s square, in place of square we will put here s plus a square plus, and this term means here it is 1, so 1 square. Okay, so Laplace transformation of e to the power 2t minus 2t cos t equals to s plus 2 upon s plus 2 whole square, and here it is not hyperbolic, so plus, and 1 square means 1, so we will have here s plus 2 upon s square plus 4 s plus 4 plus 1 means 5, this gets converted it as s plus 2 whole square plus 1 is s square plus 4 s plus 4 plus 1. Why 4? That is 2ab, a plus b whole square formula is a square plus 2ab, a is s, 2 times s times b is 2, so 4s, and b square is 2 square means 4 and plus 1, so this gets s square plus 4s plus 5. Now Laplace transformation of t square times e to the power minus 2t times cos t will be given as minus 1 to the power t square means 2 to the power derivatives 2 times ds square, and s plus 2 upon s plus 4s plus 5 means u by v form, and you know the formula for finding the derivative in the form of u by v, derivative of u upon v with respect to x, u upon v will be given as v upon du upon dx minus u times dv upon dx upon v square. So we are going to use this formula for finding the derivative of this term. So we need to find the derivative twice, so I am going to show you the how to find the derivative for this expression. Let me use a paper. So let's find the derivative for first time. So we will write here d upon ds s plus 2 upon s plus 4s plus 5. This is s square actually, and this is also s square, sorry for my mistake, s square plus 4s plus 5. Okay, now u upon v. So we will use this condition, that is v times means v means s square plus 4s plus 5 times ds plus 2 upon ds minus u means s plus 2 times ds square plus 4s plus 5 upon ds upon v square means s square plus 4s plus 5 square. Now on doing the derivative, we will have here s square plus 4s plus 5 times derivative of s means 1 and plus 0 means 1, so minus s plus 2 times derivative of s square means 2s times derivative of 4s upon s means 4, so plus 4, and derivative of this 5 will get 0. How this happened? See here, what is happening here, ds square upon ds plus 4 times ds upon ds plus derivative of 5 times ds. Okay, we are multiplying this whole terms with d upon dx, so derivative of ds square upon ds will be 2s plus 4 times derivative of ds with respect to s is 1, and this 5 will get 0, so what we will have here, 2s plus 4, so that is what I have written here. Now s square plus 4s plus 5 whole square. Now do the multiplication here, so we will have here s square plus 4s plus 5 minus 2s square plus 4s plus 4s plus 8, s square plus 4s plus 5 whole square. Now we'll need to do the solution here, so we will have here s square plus 4s plus 5 minus 2s square plus, sorry, it will get minus on multiplication with the minus sign, this is 4s plus 4s means 8s, and minus will get minus 8s and minus 8, and s square plus 4s plus 5 whole square. So on doing the subtraction, we will have here minus s square minus 4s minus 3, take minus common, and here we will have here s square plus 4s plus 5 whole square. So now we need to find the derivative of this term u upon v. Why? See here, we have d upon d s square upon s plus 2 upon s square plus 4s plus 5. This is actually written as d upon ds times d upon ds times s plus 2 upon s square plus 4s plus 5, and we have solved up to here only, so we have to do the derivative of this term what we got on finding derivative of this. So we have one more derivation here, that is d upon ds and minus s square plus 4s plus 3 upon s square plus 4s plus 5 and to the power 2. So again we will use the same rule, that is u upon v. So on using that, what we will have here, again the formula is going to be v times, so write the minus sign here in front of this division, this minus sign. So we have here v times means s square plus 4s plus 5 whole square times v times du upon ds means derivative of s square plus 4s plus 3. I am going to do this directly, so derivative of s square is 2s plus derivative of 4s is 4. Okay, this is the derivative of du upon ds. Okay, this is the derivative of u term. Now minus v times du upon dx minus u times, so s square plus 4s plus 3 times derivative of this term, So s square plus 4s plus 5 whole square derivative. See here how we can do this. We have to find a derivative with respect to s of s square plus 4s plus 5 to the power 2. So again this is will be s square plus 4s plus 5 to the power 2 upon d s square plus 4s plus 5 times derivative of s square plus 4s plus 5 upon ds. So it will get 2 times derivative of x to the power n, means n times x to the power n minus 1. So s square plus 4s plus 5, and it will get multiplied with 2s plus 4. This from here and this from here. Okay, so we will have here two times s square plus 4s plus 5, s square plus 4s plus 5 and 2s plus 4, 2s plus 4 upon s square plus 4s plus 5 to the power 4. This is v square, actually we have u upon v, so on lower portion we will have here, this is 2, so 2 square you will get 4. So this is, now take common, we have this s square plus 4s plus 5 and 2s plus 4 common, so we will take common here. So minus s square plus 4s plus 5 is common in both, so take it as common. So in the bracket we will have here, from these two we have remaining s square plus 4s plus 5 minus 2 times s square plus 4s plus 3 s square plus 4s plus 5 to the power 4, and divide this, we will have here 3. Now we have to do the multiplication. First of all we will solve this term, so we will have here minus 2s plus 4 times, on solving this we will have here s square plus 4s plus 5 minus 2s square minus 8s minus 6, and in lower portion we will have here s square plus 4s plus 5 to the power 3. Now do the final solution, so we will have here minus 2s plus 4 times minus s square, this s square minus 2s square minus s square, and plus 4s minus 4s will get minus 4s, and plus 5 minus 6 is minus 1, and in lower portion we will have here s square plus 4s plus 5 to the power 3. Now do the multiplication of these two terms. First of all we need to multiply this whole by 2s, and then again we will multiply this whole by 4. So on solving this I am going to write the final answer here, which will be equals to and this minus 1 square is going to be 1 times, and on solving this we will get here, and what we will do here, on solving this whole we will get the final answer as 2 times s to the power 3 plus 6 s square plus 9s plus 2 upon s square plus 4s plus 5 to the power 3. On solving this we will get this answer, and this is our final answer. I hope you understood this lecture. See you in the next lecture. Till then, stay safe and take care of yourself And if you guys have any kind of problem, then write me at my email address. I have provided in the link, provided the email address in the description. I will provide you the solution through the email. And in the upcoming lecture we will discuss about how to solve the numerical when we have division by t. So that is a bit different from what we have done in this lecture, so do not miss that lecture also. And do subscribe the channel if you do not want to miss any update. There are more yet to be delivered. I will also discuss about the derivative, integration, limit and continuity. So stay connected with this channel. See you in the next lecture. Till then, stay safe and take care of yourself.